it used to be a joke that quantum computers are 10 years away, and next year they'll also be 10 years away, and in 5 years they'll also be 10 years away. We're not there anymore.
Welcome to Tech Talks, brought to you by Harvey Nash and hosted by me, David Savage. On today's show, my guest is Yuval, the Chief Commercial Officer at QuERA Computing. We're talking all about quantum computing, Sam, something that you are an expert in, right?
Oh, absolutely. Yeah, I'm fully aware of all of it. I knew it all before you even spoke.
I'm teasing, but I think there's a serious point there, which is this is an area which is still considered theoretical for a lot of people. Yeah. But today we're talking about quantum readiness. And he said AI. That's like, I'm so used to saying AI. Oh dear.
An episode not on AI.
Well, it does touch on AI, but no, quantum readiness and how it actually applies to enterprise business today. So quite interesting.
Yeah, and I think actually, ironically, not really knowing anything about it is kind of part of it, right? Like, I think I was saying before we hit record that I'm not hearing, granted, I'm not in the spaces, but I'm not hearing a lot of people talk about it. So maybe the readiness is not there. I think
you'll be surprised. You'll be surprised.
Maybe. But yeah, I'm not in the spaces, but I think we've had people talk about quantum on the show before. It's coming. It's going to be big. It's possibly going to be the next AI or whatever craze once it.
I genuinely think that if quantum is realized, it'll be the biggest thing since the invention of the internet.
Wow. But at the moment,
it's closer than you think. Anyway, we'll save that for the interview with Yuval rather than us to kind of speculate when we don't really know what we're talking about. What we can tell you, something that we do know about, is that today is Sir David Attenborough's 100th birthday. And look, to some of our listeners around the world, that might mean very little, but here in the UK, that is a big deal.
It's a big deal. Yeah.
We're talking about a TV producer, effectively, who makes documentary films, who there are celebrations across the country for his 100th birthday. This isn't a queen. This isn't, I don't know, like, this is just a guy who's very successful in his field that is celebrated.
Oh, he's become so much more, right? For the country, for animals, for sustainability. For animals in general, he is. I mean, he's kind of the
nature.
I think in a very, very different realm, kind of the I'm trying to think of what's the Australian guy that
I'm
the Australian guy that died
Steve Irwin
from the
obviously that was
English
no hang on, that's seriously casting shade on Sir David Attenborough. He is so much more than that.
I think if you spoke to an Australian, they'd probably be like, he's a national treasure in the way that Sir David Attenborough is.
Australians, correct me if I'm wrong, but I think Sir David Attenborough is on a completely different level. Anyway, the reason why we mention it, because obviously it's got nothing to do with tech, big deal in the UK, but we've had some really great green tech businesses, sustainability focused businesses on the show. And we have 3 that we were going to pick out. Sam, one of yours is a bit of a passion. I mean, F1 is a passion, but
F1 was very cool, but obviously then we've spoken to Formula E. F1 are doing their own things for green tech, but obviously Formula E is green. But yeah, I'm as we've discussed before, I'm partial to everything that goes up in the sky. So I did enjoy Whisk. Whisk is a good one. Of autonomous.
You're throwing
flight.
in a 4th. There we go.
Yes. Yeah, autonomous flight, and I mean it's not quite planes, but essentially air taxis that will obviously be electric or whatever. Very, very cool. We've had, like we said, Formula E.
I was going to mention eAgronom.
AeroWare. Yes.
So we had Robin Salux, the CEO of eAgronom, who basically was talking about how dirt is the world's best carbon capture. And then you've mentioned AeroWare there.
Yeah, well, I've since actually added AeroWare to my Strava as well, so we both have AeroWare. Thankfully, I think we both have pretty decent air quality.
I would hope you've got good air quality in Brighton.
Yeah, I went for a run recently, and I checked AirAware, and it was, I think, in the high or mid 80s. Is that good?
I
Is
don't know.
that
We
what
should
you're
compare. We
usually?
should have a look at our various different
Yeah,
runs and have a look how our air quality
yeah,
compares.
because I think yours should also
It
be
should.
pretty
I'm in
good.
the
You're usually
countryside,
running out in the countryside,
but probably not as good as it should be, given
so
we're only 40 miles from London. Anyway,
yeah.
some green tech businesses that we've had on the show. Go check them out. Formula E, Whisk, eAgronom, AirAware, all doing amazing stuff, and I think ties in beautifully to Sir David Attenborough's centenary celebrations. You mentioned as well that is it this weekend that
Absolutely.
if you're called David, you get free stuff?
Yeah, there's I
fantastic.
think everyone's probably going to jump on it, right? But there are specific parks and different attractions that I've been seeing promoting basically around the UK that if your name is Dave or any kind of David
It's
variation,
got to be David.
then
I would never imagine anyone calling
David
Dave
and Dave's.
Attenborough.
I think Dave's are
Okay.
getting included.
I suppose
Apparently.
all Daves are David.
So check out any local parks or attractions that you have near you, and if you've been putting off going somewhere, then one of you can get in for free. I mean, my granddad's also called David, so I'll let him know and see if he's, maybe you can go, I don't know, maybe Bedgebury might be doing something. Or
anyway, getting back
local.
to the interview, let's get into it with Yuval on quantum computing. But Sam, what is one of the benefits of quantum computing? It's potentially very green.
That's how much I know about.
It's potentially very green.
I did think, I was wondering if it
uses far less resources.
Quite...
There's exponentially more compute power for a fraction of the resources needed. So in terms of very data centers, etc., there's some big potential savings there, which is great for the planet.
Water saving.
So there's a nice little segue from Sir David Attenborough into quantum computing, and we'll hand over to our interview. So today I'm joined by Yuval Boger. How are you today?
Very good. Thanks for having me, David.
Well, thank you for joining me. It's quite early where you are, right?
It is 6 a.m., yes.
Okay. Very much appreciate you joining me there for this early call. You're the Chief Commercial Officer at QuERA? I need to make sure I get this right. QuERA, so I'm guessing it's QuERA, but you can kind of correct me on that.
There's a school of thought that says QuERA, quantum era. There are others that QuERA. So as long as you spell it right, I think that's what matters.
Well, look, tell us a little bit about the business and your role there, first of all. Let's set some context about that.
So we make quantum computers. The company is based in Boston, Massachusetts. It's an outgrowth of the work of some amazing professors at Harvard and MIT. There are multiple ways to build quantum computers. If you Google a quantum computer, you're going to see these golden chandeliers that are usually associated with trying to cool quantum bits, qubits, to almost absolute zero temperature. We don't have those. We use a technology called neutral atoms, where our qubits, our quantum bits, are individual atoms. They operate at room temperature. These products work. We have a system that is accessible on the Amazon cloud for 3.5 years now. We have a system that's deployed in Japan, and we have researchers from all over the world that can use it, explore some really amazing applications.
And look, I suppose it would be worth kind of diving into a bit more detail about what we mean by they work, because in most people's heads, quantum is something that is theoretical that we're working towards. So when you say they work, what kind of level of computing are we talking about?
Well, they work in the sense that you could run a program and get results, and the results are real. So it's not just a drawing board. It's not just a theoretical concept. One day you could do this. Having said that, quantum computers today are limited. They're limited in the sense that there's not much that you can do on a quantum computer that you could not achieve, you could not simulate on a classical computer. Having said that, quantum computers are getting better and better, larger and larger in terms of the capabilities, the number of qubits, and we're rapidly approaching the point where quantum computers will exceed in their computational capability what could be done classically, which would mean that you could start solving problems that you cannot solve on classical computers. It might mean that you can get either better results or faster results, or just results that are similar in quality but require much less power. There's a lot of talk about data centers taking gigawatts and gigawatts of power, and the ability, at least using our technology, to do that much more efficiently is also attractive to companies. So really getting close to that point where quantum computers become more than just a scientific instrument for exploration and approach really becoming truly useful business tools.
Yeah, that's an interesting point that you make about the data center comparison. I've spoken to people about quantum computing on the podcast on a number of occasions over the last 2 or 3 years, and that promise of vast potential compute power, but a fraction of the use of resources, far less space when it comes to server racks, etc., is really appealing. Does that translate to it being more accessible to more businesses, or will there be very high costs that could act as a barrier initially as well? I mean, how available will this actually be to the majority of enterprise organizations?
That's a fantastic question. And if we were taking a plane analogy, some people ask us, are we building a Boeing 777, which is widely accessible? Many airlines have it, or are we building a B2, which only one or two governments can afford? Very, very specialized plane. And the difference is really in the way you build that quantum computer. So I mentioned superconducting qubits, those qubits that you cool to absolute zero temperature. Our approach, which uses individual atoms, perfectly identical atoms, and other use, photons or silicon qubits and so on. So there's a lot of debate on what's the best way. And when an interesting way to answer the question is to go to a vendor and say, okay, how many qubits do you really need to build a truly useful computer? One that solves an optimization problem, or one that, God forbid, can crack the internet encryption, RSA 2048. How many qubits do you need? How large will it physically be? How much energy will it consume? And how much will it cost to build? And in some approaches, the answer is, it'll be the size of a football stadium. It will take 100 gigawatts of power, and it will only cost us $1 billion to build, which makes it a very elite computer in terms of very few people could afford it, could find a place for it, and could deliver the power to it. Our approach is dramatically better. We believe that such a computer built using our technology will be roughly the size of 2 large dining tables. It could take maybe 50 or 100 kilowatts of power, not megawatts. Our existing computer runs on about 10 kilowatts of power. That's about 4 hair dryers. And it would be expensive to build, maybe 10, 20, 30 million dollars, but not $1 billion. And therefore, we believe it will be much more affordable, and so many more organizations, whether governments or universities or large companies, could afford it. Not to mention that such computers, even like the one we have today, will be accessible on the cloud. So you can use fractional capacity and just pay per use instead of having to actually own the machine.
So I think this is interesting because you've got a quantum readiness report that goes live. Is it Wednesday next week, or has it gone live Wednesday this week? Sorry, just to get that point of clarification.
Yes, I think it went out yesterday, and people
yesterday, so Wednesday this week. So it's live now, and if we could get a link, we'll make sure that we put that in the show notes if people are interested to have a look at that report in some detail. One of the stats in there, and I want to make sure I get this right, is that quantum investment is tightening. 46% of organizations expect quantum budgets to be flat in 2026, with just 10% anticipating cuts. How much of that, though, is tied to people's understanding of the context of the conversation we've just had? I suppose understanding how much investment is going to be put towards quantum also is defined by how well you understand what we really mean and what the costs, etc., involved are really looking like they're going to be for the majority of organizations.
I think the market is really maturing, moving from hype-driven investment to proof-driven investment. So a couple of years ago, you might have seen these, sort of breathless headlines. quantum computers will solve all the world's problem, and I'll have a quantum computer in my pocket, or you could do this and you could do that, and new drugs and new batteries, and part of that is true, not the quantum computer in the pocket. Quantum computers will be able to solve some problems, some of them truly important, that classical computers cannot. But it doesn't happen overnight, and it doesn't happen today. So while people were excited about new technology, like they maybe were excited about fusion, right, as a new energy source, at some point you say, okay, instead of just hand waving, just show me. Do you have a quantum computer that actually works? Can I run a program? Can I see the result? How good are the results? How large and how soon will the quantum computer need to be, and when will it be, so I can have true business value? So companies now are starting to understand what really matters, which is how many high quality qubits do you actually have, and adjust their roadmap to say, well, okay, here's where we are today. Here's what we're going to need. How long is that going to take? And do we invest millions and millions of dollars today, or do we just prepare ourselves, start doing proof of concepts, train some people, and so on? So there's a lot more realism that has entered the conversation.
How helpful has the AI boom been, I suppose, in maturing those conversations and getting people to think about this strategically? Because I suppose if you look at AI and automation, and especially with agentic AI and so on, there's been a huge amount of projects that have failed for a lot of organizations, and that has made the industry a little bit more suspect or circumspect about how it deploys those resources. I suppose that happening now means that people might approach quantum in a slightly more mature, strategic way, right?
AI and quantum have a complicated history, but actually now a happy coexistence. There was a point in time where people said all the focus is on AI, and some were worried about a quantum winter, basically all the investment going to AI and nothing left to invest on quantum computer. That has fortunately not happened. And today we see AI and quantum as different horizons. AI has sort of an immediate horizon. If you give a company 6 months and enough money, they can build a truly useful AI system, whether it's something that chats with customers or knowledge system and so on. That's not the case in quantum computing. It's not a horizon one activity. It's a little bit longer horizon, and therefore they're not competing. But we do see a lot of synergies between AI and quantum. On one hand, AI is helping build better quantum computers in terms of design. How do you minimize the noise? How do you reduce the power? AI today is helping write quantum programs, just like you can use AI to write classical programs. But then, interestingly, there's also the other angle where quantum is helping AI. And so I'll give you an example. Today, there are AI systems that help chemists determine the compound that they want to look at. So you can go into such a system and say, I want a material that's, liquid in room temperature, that's blue in color, that I could do this and that. And the AI system will say, well, here are the kind of compounds that you should be using. Well, how does AI know that? AI is looking at 200 years of experimental chemistry and say, based on everything that we have measured, this is what I expect. But if quantum computers can simulate the properties of materials that have not been tested in the lab, it actually ends up expanding the knowledge base of these AI systems and allow you to explore new compounds. So we really see that synergy between AI and quantum, both AI helping quantum as well as quantum helping AI.
How much, I suppose, of the development of quantum computing is reliant on government? You mentioned government about 5 minutes or so ago. And if I think about the UK, we've had stories of huge levels of investment. I think in March 2026, the UK government committed around £2 billion to a national quantum scaling and procurement program. We've got the National Quantum Computing Centre. Does quantum scale and thrive without that level of government backing? or can industry, can enterprise very much be at the forefront, or is it just a symbiotic relationship?
So you're absolutely right. Governments are investing a lot of money in quantum. We are privileged to be also part of the UK quantum program. We have an office in Harwell. We're building a next generation computer there. And so I think the answer to your question starts by saying, okay, well, why are governments interested in quantum? Is that just charity, or is there something else behind that? I think governments around the world see quantum as both a national security imperative as well as an economic security opportunity. So let's unpack them. On the national security one of the things that has been, um, in a way, scaring enterprises and governments is the potential ability of quantum computers to crack encryption, right? So much data in the world is encrypted, and if all of a sudden I have a quantum computer that could crack encrypted state secrets or unpack credit card transactions, or that would be a big deal. And so you're saying, well, I as a government should really have one of those computers because I would be at a big disadvantage if I didn't have it and one of my adversaries would have it. So sort of this cryptanalysis is really a big sort of fear driver. On the other side, there's the opportunity driver. You look at historical new technologies, whether the internet or cellular communications or AI or autonomous driving and so on, and say they have generated so much economic activity. A country may say, "Oh, we missed the 5G wave, and if we had 5G companies, there'd be so much, high paying jobs and economic activity, and we don't want to miss out on quantum." So if you think that quantum computers can help you discover a new drug or create better EV batteries or optimize traffic patterns, you say, I really should build a nucleus of knowledge and expertise and equipment and people to take advantage of this opportunity so that I have our own quantum computers. And this is why governments are investing so much money, both because of the fear as well as also because of the opportunity. If governments did not fund quantum, then yes, I mean we as QuERA, for instance, have raised last year close to $250 million, and it came from Google and SoftBank and Nvidia, and so we are very fortunate to enjoy government funding from the UK, from the US government, from the Japanese government, and others, but we could still have managed. But government certainly helps us both accelerate the progress as well as align our roadmap to what is important to governments.
Does that increase considerations, I suppose, from a procurement point of view around sovereignty? If a government is thinking about this very much from a potentially a security point of view, there is an increased relevance, I suppose, in the conversation of sovereignty. Like we often talk about AI, we talk about the kind of the differences in approach between various different areas of the world. You think about kind of the US versus Europe versus China and their approach to regulation. But this is that stepped up another layer. And despite quantum potentially being available in the cloud, I suppose organizations do have to take that into account when they're beginning to kind of plan and deploy resources, right?
Absolutely. I mean, you think about who your geopolitical partners are and who your adversaries are. So, just to take a hypothetical example, let's say you're the French government or the German government. Would one of them be comfortable that there's just a quantum computer across the border at the other government and saying, well, if we ever get into a conflict, would the French government really allow the German companies to use its computer? Or maybe, by the way, just could be a capacity issue. Maybe it's so important that you just are giving preference to French companies over someone else. So when you look at it as a critical resource, just like, oh, what if we didn't have internet, or what if we didn't have enough fuel to run the cars, or what if we didn't have enough electricity? Then quantum computer does become a sovereign issue. And it's not just the computer itself. People are starting to think about the supply chain. Well, what components is this computer using? And am I going to be able to get them in a crunch? Do I have local suppliers? Now, of course, it would be, some of the companies that deliver parts to quantum computers are only 4 or 5 person companies. that's something that's going to be difficult to replicate across 50 nations that want their own supply chain, right? So you do start form some geopolitical alliances or some other ways to solve it. But yes, sovereignty is really a big issue.
So we've gone quite big picture there with geopolitics and kind of some hypotheticals. But if we bring it back to a CIO, a CEO, a CFO making decisions for an enterprise business, what are the key considerations that they should be thinking about today, perhaps, if quantum is part of their IT strategy in the future?
So we see CIOs, CTOs, and CISOs, by the way, Chief Information Security Officers, thinking about both the threat and the opportunity. And it's always fun, it's nicer to speak about the opportunity, right? So if a quantum computer could optimize supply chain, let's take a simple example. Let's assume I'm a DHL and I have a quantum computer, and the quantum computer could allow me to select better routes for my drivers so that packages get picked up or dropped off faster, that I'm saving on my fuel cost. If I have that running in production, I could be reducing my energy consumption by not the electricity, the fuel consumption by 10, 20%, which would be a huge boost to my bottom line. So you start saying, well, if I could do that with some investment, that would be fantastic. It would give me huge competitive advantage. And of course, you could turn it around and say, if I'm FedEx and I'm not doing that, and DHL is, and one day I wake up in the morning and DHL can do things much cheaper than I can, or if Merck wakes up in the morning and AstraZeneca can detect or develop new drugs much faster than them, then wow, that would be a big deal. So companies are investing in that. Now, given what we had discussed earlier, is that quantum computers are some people say quantum computers are toys, expensive, beautiful, complex toys, but in the sense of their immediate utility. I think the big questions that CEOs and CIOs are asking is, how soon is that going to happen? So if the hardware is here and I need this kind of capacity to do something useful, is this a 3-month gap or is this a 10-year gap? How soon is soon? And it turns out that gap has been rapidly compressing much faster than people had assumed, even industry insiders. And that's happening for 2 reasons. One, the computers are just getting better. You're getting more qubits, you're getting better qubits, you could run longer, more sophisticated application. But on the other hand, the software requirements are actually compressing. Part of that is through AI. You're saying I can generate more efficient programs. Some of that is through just innovation and ingenuity of researchers and companies that say, I could do that with half the resources. I could do that with a quarter of the resources. So if you thought it was 10 years and now you say, well, it's 2 years. So if I'm here and in 2 years I could do something truly useful, how do I prepare? You're not a physician, I think, David.
Sadly, no.
I know the parents have regrets, right? But but let's assume that it was super important to you to pass a medical exam in terms of a licensing exam. And if the licensing exam was tomorrow morning, there's no chance that you'll be able to pass it, right? Even if you cram all night, there's no way you could, from where you are today to tomorrow morning, you could know enough to pass the licensing exam. But if it was in 2 years and was sufficiently important to you, you say, well, I could come up with a plan and I could hire consultants and I could go to night school or whatever it is I need to do to get there. Same with quantum. If you start thinking that it's in 2 years, and you may or may not have the people who are experts in writing the algorithms, and you may or may have not chosen the right suppliers for you, and you don't know how to connect it to your classical systems, and you don't know which kind of problems are truly useful and which are not quite there. Well, 2 or 3 years gives you enough time to prepare, but you have to start now. You can't wait until, tomorrow there'll be a quantum computer that solves all the world's problems, and now I have to think about it. There's also a rush to hire the experts. Also taking the AI analogy, companies that were late to the AI race ended up hiring second-rate or third-rate experts because all the top ones were already taken by other companies. So CEOs and CIOs are more seriously looking at what can be done, how soon, which are the who leads this industry in terms of the capabilities, how do we engage with them, and the best time to get started is yesterday. But if you haven't done that, then today is the second best time.
But you run your own podcast, the Superposition Guys podcast, and it talks about the technical and business aspects of the quantum ecosystem. So obviously you're well versed in this, talking to people who are well versed in this. There'll be less that shocks you than would shock me or our listeners. But what has surprised you in those conversations in recent months? What is coming out of those conversations that perhaps is ahead of schedule, even as far as you were concerned?
The progress towards true utility. The true ability of computers to be. People aren't. It used to be a joke that quantum computers are 10 years away, and next year they'll also be 10 years away, and in 5 years they'll also be 10 years away. We're not there anymore. People are looking at this as serious activity. They see the money coming in both from private investors as well as companies. They see today at last count, there were 84 companies that were building quantum computers. Not all of them are going to survive. Not all of them are as advanced. They're as well funded as QuERA. Not all of them have taken the right approach. But you see so much activity, and you say it's very unlikely that just everyone is wrong, that this is never going to work, right? That would be just unthinkable. So we don't think that quantum is now in terms of true utility, but we think that the future is coming closer than you think. The future is closer than you think.
Yuval, it's been a pleasure to speak to you. Thank you very much for giving up some time. If someone wants to listen to the Superpositions Guys podcast, how would they find it? Is it on Spotify, Apple, all the usual places, or?
Yes, to all. And by now, I've had the pleasure of interviewing more than 150 CEOs and leaders, and we're having fantastic conversations. It's a really good place to start. No physics required. No equations are posted. So, David, thank you so much for having me today.
Thank you.
Tech Talks is hosted and edited by David Savage. It is produced by Nash Squared. And we have special thanks to Lemsey for supplying music to this show.